law, and so on. Our interns got the chance to work in cross-functional teams on this through what we call Capstone projects. They explored and analyzed, provided insights, built and deployed models, and are now ready to share their findings of the datasets used with you. I'd like to specially welcome all members of the different data communities here present, Amoye Fellows, Amoye Internship alumni, and all our incredible interns who have made it this far. Hearty congratulations to you for the grit and excellence you've displayed so far. I'd also like to welcome our judges, first of which is Biodun Awujabi, who is a customer engineer manager at Google and an adjunct professor of cybersecurity at the University of Dallas, Texas, the United States. Biodun is also a creative technology architect, cloud computing expert, and an amiable mentor. Hello, Biodun. Thank you for joining us. I don't think Biodun is here, but let me just go ahead to the next judge. We also have Charles Adetiluyi, CEO and co-founder of one of the most successful providers of consulting services and builders of large-scale distributed reactive back-end systems, Maven Code. Charles has over a decade worth of experience in machine learning. Good to have you to join us, Charles.
Yeah, thank you. Thanks for having me. Nice to meet everyone.
Thank you. Moving on to the last judge for today, we also have here with us Wale Akinfaderi, who is a data scientist at Amazon, an expert in machine learning, deep learning, statistical experimentation, and general information theory. He consults for startups in data science and artificial intelligence space. Thank you for joining us, Wale.
Yeah, thanks for having me. I'm excited to be here.
All right, so those are the three judges that will be assessing the presentation. I'll now hand over the mic to the moderator, Mercy.
Hi everyone, welcome to the Capstone Grand Finale presentation for the summer cohort. All right, so before we go into the presentations proper, please take note of the following. Each team will only have 5 minutes for their presentation. You will be given a warning to round up at the 4 minutes, 30 seconds mark and stopped once your 5 minutes is up. If a team is not available for its presentation at its allocated time, that team will complete their presentation. At the end of every presentation, we will hand over to our judges for their questions and comments. Every judge has an allocation for each team that they would comment on or ask questions, require their answers for. Feel free to use the comment sections for your comments and contributions. You're not allowed to speak or barging on anything. And finally, dear presenters, try your best to be concise and straight to the point. Remember, you have just 5 minutes. All right, and now without further ado, we'll now hand over the mic to our first set of presenters for today. Samuel Owusu and Omotosho Temitope of the algorithm team. It's over to you now. Samuel in Tokwe. Algorithm team, do we have you? Where are you?
Yes, ma'am, we are here.
All right.
I'm waiting for my colleague.
Your 5 minutes already counting, so you might want to get. Thank you.
Can we all hear me?
Yes, we can hear you.
Good afternoon, everyone. All right, good afternoon, everyone. Happy National Cybersecurity Awareness Month. We are Team Algorithms and Exposure. I am Omotosho Temitope, and I'll be presenting with Owusu Samuel. Here are the names of other active members in the team. What is a vulnerability? A vulnerability is a software coding error that is used by hackers to enter an information system and perform unauthorized activities while posing as an authorized user. This led to our problem statement. Every year comes with numerous cases of software vulnerabilities, and about 80% of released vulnerabilities are not exploited. So it is critical to assess the severity of the vulnerabilities rapidly. But manual estimation of the severity metrics is time consuming. So we developed a faster way of assessing the vulnerabilities. Our project aims to automate the entire process of estimating the severity level of the software vulnerability. To predict the severity matrix, and a random seeing the output of the bet for this project. The data set was from 1999 to 2019. Features included CVE ID, CVE name, summary, etc. We had 4 data sets to work with. We meshed them together and we had an approximate of 242,000 rows and 15 columns. During data cleaning and preparation, we dropped missing values and duplicates from the data set. We also passed the date column to date time format for our data set. Now to our exploratory data analysis. For vulnerabilities per year, 2018 was the most vulnerable year, while 2001 was the least vulnerable year. For our severity distribution, we had more occurrences. We had more occurrences of medium severity cases. Also, for the top 25 products, Ubuntu Linux was the most affected product, while Windows Server 2012 was the least affected product. We also created a Power BI dashboard with other visualizations as seen. Text processing like tokenization and the likes were performed on the input text, and the words were vectorized with one-not encoding. The generated vectors were trained on 7 different models, and they were evaluated their performance on each target using with the embeddings of the text. Where the output of the best model was then fine-tuned to a multi-class multi-output model with a dropout of 0.1. The outputs from the best model were passed into a random forest regressor for the prediction of the severity score to determine the level of severity. This is a schematic for our model architecture. For our model performance on the severity matrix, this is a table that shows 7 different models with best model performing best. For our model performance on the severity score, this is a table that shows 9 different models that we trained with random forest performing the best. We evaluated the best model using other evaluation metrics. Looking closely at the accuracy and F1 score for the best model, they are quite close compared to other models. Also, we had a RMAC score of 0.023 and an MAE score of 0.00054 for the CVSS score. For our model deployment, it was saved and the user interface was created using Streamlit. We have a video that we are supposed to show as a demo, but I don't know why the video is not coming up currently. The uniqueness of our project is the ability to correctly predict the CVSS metric of our
30 seconds more.
Uniqueness of our project is the ability to correctly
from
predict
CVSS of revenue when exploited. Our project helps vendors analyze metrics that are making their product variable in order to predict, improve each metric. As a recap, we built 2 different models and created a user interface on Streamlit. We faced some challenges during the problem. A lot of time was needed to gain adequate domain knowledge about the cybersecurity field. In addition, time was a problem and limited resources. Lastly, we had issues with the deployment on Heroku because the slug size was higher than the maximum requirement. But all in all, it was a worthy learning experience. Thank you so much, Amoe. Really appreciate this opportunity.
Okay, awesome. Well done, Samuel and Temitope. All right. Charles, sorry, you're not supposed to be on this. You're not supposed to judge this team, but Biodu isn't here. So you're going to help us cover for him. Do you have any questions or comments for the team?
Yeah, that's fine.
Please, I want to confirm that Samuel is still on the call.
Yeah, I'm on the call.
Samuel is still on the call.
Yeah, I'm on the call.
All right. Thank you.
Sorry about that, Charles. Please go on.
Will you be able to share that video and drop a link to it on the chat so that we can look at it? But all in all, I think this is very
okay.
This was a very good presentation. I like the way you went about it. So
okay, this is the video actually. Can I play it?
You can play it and put it on mute while we talk through it so that every other person can see. So my question for you was, the vulnerability signature changes from year to year. How do you make sure that you capturing all the changes and vulnerabilities? Like you said, 2008 was very severe. 2001 was the least severe because of COVID. So how do you basically get a signature scan of what's going on and be able to improve your model yearly, or depending on the cadence, improve your model maybe month to month or week to week? Can you talk a little bit about that, or you didn't think about that?
Based on the severity, looking at the trend of the severity from 1999 to 2008, we noticed that there is a high increase from 1999 to 2019. And looking at the pattern of the severity score, we noticed that 2018 had the highest number of severity compared to other years. And looking at the trend, so we actually use time series to actually generate the CVSS score for us to see how the trend is going. And we noticed that going down, we are noticing that the CVSS score.
Wait, can you take over for Samuel? It's breaking up.
Oh, okay. So what he was trying to say. Sorry, can you hear me? Hello, I want to be sure you can hear me.
I think I can hear you.
Can hear you clearly.
Oh, all right. So what he was trying to say is that we noticed a trend in our data sets from 1999 to 2019, and 2018 was the year with the most vulnerability. So we ensured that we built a time series model and checked if our data was stationary or not. So when we saw that our data was stationary. So with this, we were able to confirm that this model, in a way, would serve greatly in production if it is being used. Also, like we said, in the challenges we faced, we were not able to ensure that we improved the CVSS metrics because the BET model was quite computationally expensive. So I believe if we are able to improve that accuracy, if we have more resources, obviously over the years, we'll be able to improve the metrics that are predicted by the BET model. And obviously, if the metrics predicted by the BET model is correct, the random forest regressor would predict the correct CVSS score and will be able to categorize the severity of the vulnerability. So the severity of the vulnerability would make us know the decision to make if we are to attack the vulnerability right now or wait and look for other measures to put in place.
Okay, that's very helpful. Thank you. I'll pass it on to Juan.
Yeah, thanks for the presentation. I have a few questions. I think I'm a little bit confused about so you're predicting what the CVSS score is. So my first question is what's the range of the CVSS score? Is it severity? Is it from 0 to 1? I'm not sure.
Yeah, the range of the CVSS score. No, the range is from 0 to 10. The range is from 0 to 10. I showed it the range is from 0 to 10. Okay. And we also categorize them into 4 different categories. So the range is from 0 to 10 actually.
Okay, the range is, and then in your model output, so you have your bets that you fine-tuned and pre-trained, your pre-trained bets that you fine-tune, and then you have an output which is a random forest regressor, right? So
no, we have an output which is the severity matrix. So it is that output we pass into the random forest regressor.
Okay, so the severity matrix is so that means the output is a softmax function, right?
Yes. So we are predicting
in addition to that. Hello.
Yep.
In addition to that, the BET model will predict the CVSS metrics. There are 6 different target variables, and they are all multi-class. So now the output from the BET model will be passed to the random forest regressor. The random forest regressor will now predict the CVSS score.
Okay.
That means we're using 2 different models.
Okay, I see. So you have that as your categorical features, and then that is used to predict the CVSS score.
Exactly.
Which is okay. So back to can you go back to your model metrics, please? Your evaluation metrics, yeah. Not that one. Okay.
All right.
Okay. I see. Okay, so that's where your random forest regressor shouldn't be giving you an accuracy.
That's the R2 score, sir.
No, it is the root R2 square error. R2 square.
Okay.
Score, rather.
Okay, it's the R squared. Okay, it's not the accuracy. Okay, that was I think that was one area where I was able to be confused. And then okay, I can see.
Yes.
All right, thank you. Yeah, that clears it for me. Thanks.
All right, thank you so much.
All right, that's for that group. The next group up is Anaconda. And can we have the presenters, please? Anaconda group, you have the floor. Anaconda. That's Olajimeji Williams and Stuti Subramani, I think.
Okay, so I'm just given the permission now. Can you all hear me?
Yes, we can hear you.
Okay. Hi, everyone. Olajimeji Williams is my name. Myself and my colleagues, Stuti Subramani, will be standing in for Team Anaconda in presenting this project titled Supreme Court's Prediction. Here's the list of the other active members. Over the years, people everywhere expect justice to be served. The ability of the Supreme Court to provide true and fair justice to citizens is a primary pillar of democracy practiced in Nigeria and every other form of government practiced in other countries. So this project aims to use existing NLP algorithms to quickly know whether or not one would win a potential legal case. Most of the existing solutions to this problem use deep learning libraries, but many of the variables included in the features are related to the target variable, causing the model to overfit. But our own solution is more appropriate to be used by an individual who wishes to know in advance his or her chance of winning a potential legal case with a reasonable level of confidence. So firstly, we cleaned the data sets and removed stop words, including punctuations that are irrelevant for the model. Of course, all of these are wrapped in reusable functions. We tried TF-IDF and bag of words for feature expression. Then we trained and deployed the final model on Heroku. Originally, the dataset contained about 3,304 observations with 16 columns, including the index column and the target column named first party winner. We then had 3,159 observations after cleaning. It is obvious that the dataset suffers from class imbalance, as this count plot shows that the dataset contains over 2,000 cases won by the first party, while over 1,000 cases were lost. We can also see that the majority of the recorded cases were influenced primarily by the majority opinion of the jury. Further explorations are shown on a Tableau dashboard. Stuti, please give us a brevity.
The given dashboard provides us with a sort of in-depth analysis of the data set. So firstly, we're going to talk about the distribution of case origin state, which elucidates the information on the distribution of the Supreme Court cases along with their origin, where California is seen showing the maximum number. Now, looking at the case count by term, we can infer that the number of Supreme Court cases have substantially increased over the years, with 1997 showing the highest surge. There is also a bubble chart showcasing the issue areas featured in the data set, with the highest being criminal procedures, followed by economic activity and civil rights. Now, coming to the next chart, it can be seen that rulings were reversed or remanded in criminal procedure cases, which can therefore be concluded by the last elucidated graph, depicting that most of the criminal procedure cases had first-party winners, followed by civil rights and economic activity in the same order, meaning a lot of individuals won their case. Now, moving forward, we're going to talk about the model.
Thank you so much, Tuti. So this is the model pipeline. After exploring the data, we cleaned, performed feature extraction using bag of words, transformed the data, and evaluated about 7 models on the data sets. So when we applied TF-IDF on the data sets, Random Forest performed better with 0.787 F1 score. And by the time we used the bag of words approach, we had the 0.793 F1 score with Random Forest. So Random Forest was deployed on Heroku, and here is a demo of how the model predicted on the link. So this project, in essence, has achieved its aim, that of assisting an individual in knowing his or her chance of winning a potential legal case, even before initiating the legal action. Using Bigram for feature extraction turned out to be computationally expensive during the project timeline, as it keeps crashing both our local machine and the virtual server. Also, the major problem with this model is that it lacks the ability to repudiate meaningless text when input as facts into the model. And we are still doing research in this area. And here are the links related to the project for your per user. You can also leave nice reviews on them. Thanks.
All right, well done, good job. You finished before the time. That's cool. All right, so Charles and Wale would help us again with this group. Questions, observations, advice, anything you have for them in Anaconda.
Can you go back to that visualization where you have that graphics? I just want to understand what you're trying to like pass through. I think you moved a little bit too fast on it. Yeah, there you go. So
Okay.
What were you trying to do here? If you can go through each one by one.
Stuti, would you like to talk here, or should I go on?
Yeah, you go for it real quick. Let's keep moving.
Okay. So here we're just looking at the distribution of the case origin by states. So we have cases as the observations. So we're trying to look at the states that has the most frequent cases recorded in the data set. So here we can see kind of
the ones that are blank, are they without case? Like you have I think Utah, North Dakota, South Dakota, and they don't have anything showing up there. Is it that there's no case or there's nothing to worry about in those states?
I think it's nothing to worry about because it means that they are not represented in the data set. Also, we have some missing data, of course, they are not much. So just like a few over hundreds in the data set that are missing. So this probably represents those states that they have no data. So these are the states represented in the data set. And also the data set contains cases in the United States. Is not capturing other places.
Just to be clear, I think if I'm right, this is Federal Supreme Court, right? So these are the cases that originates from some of the states. So I'm guessing,
yes.
Charles, maybe some of the states they have people that are inactive, or I don't know, maybe they don't care. Yeah,
exactly. That was a little bit. Yep. All right, keep going. So.
Okay, so the next chart is also talking about the case count by the terms. So we also see the surge in 1997 having the highest case counts of time. So, I mean, we can also see the bubble chart here because each of the cases brought up into the Supreme Court, they have their own specific issue areas. So they are like classified. So here we can see the issue areas. We can see criminal procedure having the marks, and we have economic activity area and the civil rights area, First Amendment, and all.
How do you classify them? Do you do a topic mark?
It's already classified in the
Okay,
set.
so just visualizing. Okay.
Yes, this is visualization. So we're just trying to look at the distribution, how the classification that has the most count of issue areas. So this is the visualization.
Okay. And do you have the breakdown by the states?
Yes.
For each of these classification?
Yes.
Where's that?
So come again.
I said, do you have the breakdown by the states for each of these classifications?
For each classification, no. It's only this one that we took into consideration when looking at the state.
Mm-hmm.
We've just considered the cases in terms of states and the other issue areas featured by their number, not by their states.
Okay, and did you consider them over the years as well? Like, I want to see what kind of cases are key cases in the last 5 years. Like,
Okay.
did you do that kind of breakdown?
No.
Okay.
These are just the visualizations we try to explore.
Okay. All right. Thank you.
Yeah. Thanks for the presentation and the work. It's really interesting. I have a question again about metrics. Can you go back to metrics?
All right. Here's it.
Okay. What is model score?
Yeah. So firstly, the final amount that we picked was this 0.793.
No. I'm saying model underscore score. I don't know what that is. The second column.
Okay, so there is model score. There is model score function with random forest. So
That's
it just talks about.
So that's a training accuracy.
Yes. So this one is the one on the test and
okay. That's your
so, but of course we didn't consider the accuracy. We looked at the F1 score because we have class imbalance. The classes are not balanced, so we did not use accuracy. We looked at the F1 score because it also takes into consideration both the true positives and the counterpart. So we looked at only the F1 score. We didn't look at accuracy.
So the reason why I'm asking is that the model score is a training accuracy, and look at it looks like you're overfitting.
Yes, it's overfitting. That's why we didn't even look at the logistic regression at all, because this one.
Yeah, but almost all the models are overfitting. I mean, some of them, like the random forest, it's really overfitting if you see the accuracy and the model score. So I think one thing that you guys probably didn't do is actually check for overfitting and maybe do a cross validation, or try to use some sort of regularization to make sure that you're not fitting on your training data set. So it looks like that. That's one thing I wanted to say in the model evaluation. And then the other comment I want to make is on the dashboard. I don't know if that was Tableau or BI. So I really like the idea of the dashboard. I really like that you guys are actually sort of putting together stuff in your dashboard. But for me, it doesn't tell a story, right? So, and I think Charles asked a lot of the questions about, do you have it, broken down by states? So, for example, if there is a category around civil rights, for example, right, you should be able to tell a story around, maybe in the 60s, there were more civil rights, Supreme Court cases than now, right? And so that element of storytelling is actually missing from what I can see. But yeah, overall, I think this is a nice NLP project. Thank you.
All right, thank you so much, Wale and Charles. Thanks a lot, Stuti and Williams. Good job. Okay, over to the next team. I think that would be for data warehouse, and that is Ayomide and Kazim. Oh, you're all here. All right, can begin now. The time starts now.
Good afternoon, everyone. 2 weeks ago, our team was tasked with the responsibility of looking into the gender statistics in Australia with specific interest in employees' earnings. On behalf of Team Data Warehouse, Ayomide and I will be presenting our report on gender statistics, earnings of male and female employees. Moving on. Gender equality is a social phenomenon and its effect can be observed in the workplace. Sex segregation, channeling women into lower value-added sectors is one of the many effects of gender disparity. And this data given to us, our job as a team, is to bring out insight from data provided that shows the disparity between the female and male earnings. Now, next, for the methods used in this project, we started by collecting data, after which we performed data pre-processing, then exploratory data analysis, and also performed the feature engineering needed to model our data. We also tuned and evaluated the best time series model for the trained data sets. Collected from Cargo, the data set is a CSV file with 14 rows and 20 columns, which contains the average hourly earnings of different gender for the specified period, 2004 to 2017. For accurate use of the data, we had to check for missing and duplicate values, after which we renamed the columns for what? For clarity. For our exploratory data analysis, here is a regression plot showing the slope of male and female wage differences for the specified period. There was a rise in the wage difference through the specified period, except the machinery operators and drivers, which had a decrease in wage difference. Moving on, our analysis showed that the male dominated the earnings per hour over the specified period, as they have higher earnings compared to female and others who do not identify as male or female, labeled as what persons. However, as observed in the wage difference trend, right, the female machinery operators and drivers at a point in the specified period had highest earnings per hour. The box plot here shows how the male average earnings per hour is higher than the females. The multiple box plots on the right side further shows how the managers and professionals have higher average earnings per hour. The general distribution of earnings, irrespective of job category in Australia, shown on the plot here, indicates that we have minimum average hourly earnings to be about 15 Australian dollar and the maximum average hourly earnings at about 60 Australian dollar. Over to you, Ayomide.
Thank you very much, Fatai. So we created a target variable, which was our wage gap, created from the difference between the male and the female earnings for each year in Australia. Data was then divided into 10 training sets and 4 data points. From there, we decomposed our data into seasonality and trend. Of course, as we can see, that our data lacks seasonality but shows trend. Going forward into our time series analysis, we could see from our autocorrelation and partial autocorrelation that there is no significant lag from our analysis. So we noticed our data was non-stationary. So then we used first order differencing to treat this trend to make our data stationary. 2 models were used, that was the ARIMA and the Prophet. We collected our data, defined the features, created our model, trained the model, after which we tested and evaluated. So to check for the performance of our models, we used 2 evaluation metrics. That was the mean squared error and the mean absolute percentage error. We see MSE value of 0.16 for ARIMA and 0.07 MEP value for ARIMA also. So we could see that, yeah, the ARIMA is the better performing model here. So generally from our analysis, we noticed that male earn more than females. But in year 2005 and 2015, we noticed that female drivers and female machinery operators earned more. We suspect this might be due to increase in employment as at the time. And we also had challenges in our data because it lacked features and that could explain for the differences between the payment of the male and female, and also insufficient data that we could not use to reliably model our data. So from our challenges, this spurred us to encourage and advise the society, generally the government and the employers, to come up with strategies and policies that can support gender equality inside organizations, and also to come up with programs that inspire women to enroll in university professional programs. We believe with this consistent effort and intentional effort that the pay disparity between male and female will greatly be reduced. So, and with that comes to the end of our presentation. Thank you for listening.
Awesome. Thank you so much, Kazim and Ayo. All right. Wale, do you have anything for them? Wale and Biodun, we want to hear your questions for this group.
Yeah, I do. Thanks for the presentation. My question is that, how did you do the evaluation? So you had data for sort of showing like the wages, and you're actually predicting future, like how did you split your data set?
Okay, after we created the target variable, which was our wage gap, Our data was actually, we had like 14 rows. So we had 2006 to 2017.
Okay.
So coming from 2006 to 2017, we removed 10 out of that, of course, otherwisely, for the training, and also the remaining 4 for the testing. So when we predicted into, for example, so we come from 2004 to 2007. So we predicted forward with the first set and compared it with the testing set. So our testing sets were the earlier years that we had.
Okay. Okay, I see. So, okay, so it's sort of like a backward sequence. Okay, yeah, because the reason why I was asking is I was just surprised that Arima was able to beat Prophet, and not only beat him marginally, but it is a lot. So I guess, classic statistical method still works. So thank you.
Thank you very much.
All right, thank you so much, Wale.
The only question I have really is, what are some of your learnings from this exercise or this project?
Sorry, come again.
So what are some of your learnings from this project?
Okay. From this project, well, like I mentioned earlier in our summary about the challenges we had, of course, after learning with the fact that our data shows that male earn more than female, even though we saw that in our analysis, we still needed more confidence to reduce being biased, especially in our modeling and also in our analysis generally. And that was why we complained about the fact that we lacked features. So we felt that if we had enough features that could serve as factors for the reason for this wage gap, it will help us to become to relate better with our data. So, but generally, that's just what we saw. We saw, of course, that male keep any more, and they will keep any more. Of course, unless they go ahead and make use of some of our advices from the recommendation section.
Okay, I'm curious to know what the recommendations are.
All right.
Curious to know what the breakdown of the earning is too. But
okay.
Please share a little bit. I can't read this really, but can you maybe summarize?
All right. So what we recommended was that we recommend that the government, okay, from our research into finding what exactly is the cost for this particular consistent over the years. So we found out that due to gender inequality in the society, even though we claim this is 2022 and we claim that is no more obvious like before, still the effect is still quite significant in the pay disparity in all industries. So we recommend maybe better, stronger policy, gender equality in industries, in organizations. So policies like that will really help to between the female and the male. And also, we also realize from our research mentality, so mindsets, probably from the culture or from the gender, that they believe that male are the only ones that tend to do some certain things, that tend to go for some certain programs and all that. So we recommend and advise the government, the society generally, to find enlightenment programs to enlighten them so that they can be inspired to enroll in university professional program. For example, to note, this particular project it was as a result, it was inspired by one of the great women that has done so well and in the society over the years, people like me, great business entrepreneurship. So we believe if women like that come into play and inspire their fellow gender to enroll in university professional programs, that will really help in reducing the gender disparity and all that. So that's the recommendation. That was what we recommended.
All right, no problem. Thank you very much. It's a good project.
Thank you.
All right. Thank you so much, Biodun, and thank you, Wale, for your questions and observation for Data Warehouse. Thank you, Data Warehouse team. Hadu is next in line. So we'll have Abdullah Viz and Damola Babayato.
Okay, we're here. Can you let Abdullah share his screen, please?
Can I hear your screen?
All right. All right, please, can you confirm you can see my screen?
Guys, your time has started counting.
I can't see the screen.
Please, can you see my screen?
No.
I can't see the screen.
Bayato, please, can you share your screen
I'm trying
instead?
to share the screen.
Your time is really...
My God. All right, can
still cannot see your screen.
can you
Yes, we can see the screen now.
Okay.
Yeah.
All right, so our topic is on public perception of AI. And then we had three teams. So let's talk about what's AI. You can say AI is any technique that enables computers to mimic human behavior. So next slide, please. Public perception of AI. So is AI dangerous? Will AI destroy humanity? Will AI take our jobs? All these questions are what people tend to think about when they hear AI. Next slide, please. Next slide, please.
My God, my screen is using.
Next slide, next slide. Next slide. So is AI the devil of recognition, or is AI the new god? Next slide. Our data set was organized, so it gives us the general AI mode and AI relevance on a 5-point scale. It also gives us the binary indicator of if there's a negative or positive sentiment for each of the following sideboard ethics, and also how AI will affect work. Next slide. We had 3 quality issues. That was duplicate columns, incorrect data type, and also some null values in some columns. We also removed some metadata. Next slide, please. So we can see that on the right, when we remove the neutral articles, not only are articles positive around the 90s, but as we get closer to the modern day, the trend is pronounced. Next slide, please. An interesting phenomenon is around 2000, the year 2000 is when the number of positive articles increased, while it was only 2005 even for negative. Also from 2012 to 2015, there was an extremely intense increase in negative articles, likewise positive articles. Next slide, please. Next slide. So what perhaps not much of a surprise is how the effect of AI on work is the most popular topic, and it's no wonder why my job become automated. Next slide, please. The general sentiment of people about AI was 67% neutral, 29% positive, and 3% negative. Next slide, please. So we did some hypothesis testing to know what fears are increasing the fastest. There was a dip in 2016 due to the data that had been taken in 2016. So it was excluded to assist the algorithm. So we checked for the derivatives and normalized with the z-score of the derivative of each topic at 2015. So we use feature importance as feature selection using an optimal extract classifier. We train on 4 classifiers.
Seconds more.
KNN,
Continue,
extract
please.
and forest. We also calculated the AI mode category that's dominating the entire data set. So we calculated what proportion of the data set are 1s, 2s, 3s, and 4. So next slide, please. What stood out is an increase in articles per year at the z-score of 2.204. From our calculation, there was somewhat a dominant strategy for the potential machine learning algorithm to simply choose 3 as the AI mode for every single article, which gave an accuracy of 22.6. From our random forest classifier, that accuracy of 22.6.
Can you please give them 60 seconds more since they...
Okay, no worries.
Yeah, thank you.
All right.
Yeah.
So which means it wasn't using the dominant strategy. Next slide, please. Of course, our accuracy is really very good. Why is this? One possibility is that data set is really great for this machine learning algorithm. Also, we had an overabundance of 3s in our model, which may be also an algorithm. However, the fact that accuracy is above the dominant strategy means our algorithm is learning somewhat. Next slide, please. Next slide, next slide. So the conclusion was that the general feeling about AI is getting more and more neutral as the time passes. The biggest growing fears around AI is about AI coming to take people's jobs. Next slide, please. We believe our data set is a more exploratory data set rather than a more statistical one. So deploying a prediction model out of this might not only be relevant, but also the output might be very big. Also, maybe adding more volumes of diverse, unbiased data with more statistical relevance might help achieve greater accuracy and precise results for the algorithm. You can share your dashboard.
Okay. All right. So why the largest proportion of the public's perception?
Your time is up.
61%.
Time up. Thank you very much. Your grace, 1 minute grace given to you by one of the judges where you used them. It's over. All right. So we have Diodun and Charles. Please, can you make comments, questions for this group?
Yeah, I think that was a nice presentation to start with. The layout was good. I know you're having some technical difficulties, so that might have affected the delivery, but I think everything looks good from my side in terms of how you presented. So, but can you go back to that slide where you have the analysis so that we can just understand things a little bit more better? Since you're
Okay.
Yeah, can you talk through the exploratory data analysis section?
Okay.
So you said there was downward. I mean, I just want to understand the trends in the last few years. Is it like is it that people are getting more awareness about what AI is?
Yes. People are getting more aware about what AI is.
Okay, and is AI capability improving over the years? And could that be the reason why people are a lot more apprehensive?
Sorry?
Is it like because of the AI capability that is creeping into our lives day by day? Is that why people are a lot more apprehensive? What's the data telling you? Can you just go deeper and explain what you have here?
All right, sir. So in trying to investigate the trend of the relevance of the publications with regard in relation with artificial intelligence and public perception, we figured that there is a correlation between in which the more publications are made on artificial intelligence, the more people become aware and have opinions on the topic. Yeah.
Okay, can you go back to the next slide and talk through what's there? I just want to understand if no, yeah, that one. Can you talk through that?
Okay. We said around the year 2000.
Okay.
Around the year 2000 was when the number of positive articles increased, and why it increased in 2005 for the negative article. And also we said there was a sharp increase in 2012 to 2015 in the negative articles. Likewise, there was also a sharp increase in the positive articles. However, we feel like this could mean that negativity is also increasing at a much faster rate in recent years, also compared to positivity.
So how did you create this graph? How did you create this graph? Did you have the data, or did you go through the articles and you did like a sentiment analysis to mine the data and understand what's
the
sentiment is on the article?
Okay, for this we grab the number of one mode negative articles and one mode positive articles per year to know the optimism of the year and also the fear. So we store the numbers of 1s and 5 in an array. Then also we removed the first year since that was starting, and we also converted the arrays into like 2-dimensional arrays and store them. Then we also created like a data frame for each of the number of articles, number of negative and number of positive articles to graph our results.
Okay. And do you have the code base shared on?
Yes.
Okay, if you can post it to the chat, that would be very helpful.
All right.
Thank you.
All right.
Thank you.
Okay, so my only question is, if you had more time, what were some of the things that you would have loved to do that you weren't able to do?
Honestly, building a model, I was trying to know what went wrong, because we trained with 4 classifiers, and they were given like a range of 76, 75, 74, and also I even decided to use the voting classifier, but a voting classifier is supposed to help the model, but at this point it was still given like the same. So giving more time, I would probably maybe try running with in-depth NLP and deep learning.
Yeah, I didn't realize on mute. So what would that have created differently in terms of the results? What would that have given you? What other angle would that have impacted the results that you're showing today?
Because I've been able to deploy a model out of it if we had a better accuracy, because I feel the accuracy was too poor as well, and the output could have been rogue. So I believe if we had a better metrics, could have been able to deploy a model. And generally, I just feel it's sort of an exploratory data more.
All right, no problem. Thank you.
All right, thank you so much, Team Hadu. Well done. Thank you, Biodun and Charles. All right, so on to Keras. We have Aisha Pavin and Akinrotimi Daniel Feisola.
I'm audible. Hello. Hello.
I can hear you.
Yeah, okay, thank you. Okay, so today's topic for our team is breast cancer predictions, and here is here's the name of our teams. Uh, the problem statement: worldwide breast cancer is the most common type of cancer in women and second highest in terms of mortality rates. Diagnosis of breast cancer is performed when an abnormal lump is found or a tiny speck of calcium is seen. After a suspicious lump is found, the doctor will conduct a diagnosis to determine whether it is cancerous or not. So the goal for this project was to determine whether the cancer has the potential to cause harm, including death, and train a machine learning model that can predict the benign or a malignity of a cancer based on the data set provided. So there are some existing solutions in the market, there have been an algorithm developed by Massachusetts General Hospital and Harvard Medical Schools. They got the data from American College of Radiology Imaging Network and Palmer and colleagues. This is our approach where we tried reversal of the diagnosis column to correct the mislabeling or the malignancy for the tumor, and trained different models and selected the one which had a high recall value. Our data set description. So we got our data set we obtained our data set from Dr. William H. Wahlberg at the University of Wisconsin Hospital. And it was created for AI for Social Good Women's Coda Boot Camp. It includes a variety of breast cancer instances to aid in identifying breast cancer in females. So our data set included 5 features, which were mean radius, mean texture, mean parameter, mean area, and mean smoothness. And there was also an output column. So all these features are in a micrometer, and the output column included a diagnosis column, which had 0 or 1, where 0 predicted that the cancer is malignant, and 1 signified that it is benign. Some of the exploratory data analysis. So this illustrates a various distribution plot of the different features in the data set. It shows the lowest and highest value of each feature. It also shows the frequency of our values. Some of the visualization. So here there is a visualization between different features in our data set. Here we can see that there are some collinearity between different features like mean area and mean radius, and mean parameter and mean area. If we see the visualization of our output, then we can see that in our data set, like there were total 569 entries, and there were 212 records for 0 and 357 records for 1. Data pre-processing. So we checked if there are any null values in our data set. So we didn't had any null values in our data set, and we reverted our diagnosis column, that is the output column, because if you see, we segregated our data set into 2, that is where we had the value result as 0, and 1 where we had the result as 1. So here if we see, then we can see that the mean radius and mean parameter, all these values are higher than the result we found in the data set where we had output as 1. So we can predict from here that the 0 actually predicts that it's a cancerous cell. So we reverted to the diagnosis column to say that now our data set where we have 1 will contain the cancerous cells. Feature scaling and model scaling. So we converted our data set into the standard scaler. After trying all the models, we decided to go for logistic regression, and then we validated and predicted. Model evaluation. So these are different accuracies for different models which we tried. So here we can see that a logistic regression classifier gave us the best accuracy, that is 94%. However, we realized that for our use case, we don't want to take accuracy as the parameter to decide the model, because we wanted to reduce the false negative in our use case as much as possible. So here is the graph or comparison between different models. Here we can see that the logistic regression has a minimum number of false negative, that is 2 for our data set. So here we can also see that the recall value of our logistic regression was the highest compared to other models.
More, Aisha.
Yeah.
30 minutes. 30 seconds
Yeah,
more,
okay.
sorry.
Okay, feature importance. So mean smoothness and mean area, we can see that they have the highest feature importance value. And then this is the model demo. So we tried different value. We tried providing different values and predicted the predictor using a model. So here we can see that when we entered this value, we got a benign, and if we enter different values, then we will get malignant. So we tried for both. And some of the summaries and challenges. At the conclusion of the project, we were able to develop a model that accurately predicts the malignancy and benign of the cancer. These are some of the project links. We deployed our model on Heroku. Thank you.
Very much, Aisha. All right. For this round, we would have Wale and Biodun.
Yeah, thanks for the presentation. Yeah, really nice work. My other question is that if you or your team, if you guys had more time, what do you think you'd have done differently? Or what added stuff do you think you'd have?
Yeah, we were thinking that if we would have enough time, like if we can see here, then there's a high correlation between our features that we can see here, like mean radius and mean area, mean parameter, right? So we could have tried like reducing a few features and tried how our model is performing on that, or we could have tried with a different or a high data set, since now currently we only had 569 entries in our data set. So we could have tried that as well. Other thing we could have tried is maybe like this is not a very high imbalanced data set, but maybe if we could have tried handling that as well, then yeah.
All right, yeah, thank you.
Thank you.
All right, so question for me, and just kind of picking up on where Wale started. Say, for example, with what you've done, what are like the extra data enrichment capabilities that you have in terms of opportunities? So I'll give you an example of what I mean. Say, for example, your data set, does it tell, okay, African Americans or Africans or women of specific age, are more prone, also more susceptible to either malignant or true cancer lumps, if you will. Is that something your data set or the work that you've done has?
That's a good insight, actually, but our data set didn't had those parameters. Our data set only had these 5 features on which we worked. But yeah, that is a good thing. We can also try that in future.
Okay. Yeah. If you look to doing that, at least you're building your analysis on data. Nothing stops you from making this public, like your visualization, and enriching your data set with more parameters and making it public. Something you should consider doing.
Yeah, that's good advice. Thank you.
All right. Thank you so much, Biodun, for that. Thank you, Wale. Thank you, Aisha. Great presentation. Well done. All right. The next team, we have Metadata and we have Theophilus presenting. So Theophilus, over to you. You have 5 minutes.
Good afternoon, everyone. I'm going to share my screen. Okay. All right. Good afternoon, everyone. Theophilus Warren presenting on behalf of Team Metadata, the Capstone project for the HDSC Summer 2022. Our project is on mobile health human behavior analysis. We are analyzing human behavior using machine and deep learning. And these are the active members of the team. All right. Okay, so mobile health describes the fastly developing field of digital health, providing care and treatment for the population via mobile technology such as smart devices. Human behavior is diverse and complex. This nature has posed a great challenge on learning and most importantly, predicting the human behavior from daily activities. So data is undoubtedly an answer to the ambiguity surrounding human behavior and its prediction. For our project, we are looking at deriving data-driven insights from the mobile health human behavior data by means of appropriate visuals. And we are building and training a machine learning model that enables the prediction
sorry
of human
to cut
behavior.
you short, Theophilus. We can't see your screen.
Oh. I'm sorry. What about now?
Yeah, we can see it now. Thank you.
Okay. Sorry about that. So our deployment, we're also deploying a developed model to facilitate the live predictions. Okay. Our approach is to retrieve the data. We actually had the data from Cargo. We have about 1, 2, 1, 5, 7, 4, 5 rows and 14 columns. And that was the data set that we used. We prepared the data and did some visualization, then trained the model using machine learning and deep learning, then evaluated the model and deployed it. Now, this is the data description. There were 12 different activities from 3 sensor devices and 10 subjects. We have activities which are standing, sitting, lying down, running, jumping, and the likes. So these 10 different subjects were actually the ones that perform these different activities. So for the data analysis, we did exploratory data analysis, which was using Matplotlib, and we used that to infer various insights. Now, these are some of the visualizations from our analysis. Now, for the model training, we use several machine learning models, support vector classifier, and random forest and the like. This model was used to test data for predictions. Now, this for our model training, the correlation matrix or heat map that was deployed to define the correlation patterns of the variables. Now, for the model evaluation, random forest actually gave the highest accuracy using F1 score. And we didn't do hyperparameter running because it would have made the model so heavy. Now, for deployment, let me just run through the deployment. Yeah, we use Streamlit app for the deployment. So for the deployment, we use Streamlit app. So we're able to predict different activities. We already have some data completed already. So we can predict different activities and certain different parameters. So this is running, then train also another set of parameters. Predicting this will give us no exercise. So because all of this is actually 0 when it creates. So also, all right. Thank you.
Thumbs up. Thank you very much to Metadata. Okay, so for this team, we have Charles and Biodun.
Can you go through the last step again? The audio was a little bit bad on my side. If you can just explain how this works. Yeah.
Okay, so I can impute different parameters here to actually predict different physical activities. So I'm just putting some random figures. So to predict from various different activities.
That's interesting. So if I'm on the treadmill, or if I'm rowing, or if I'm running, you can determine from all the gyro sensors and accelerators on the device.
Yes.
Oh,
that's correct.
Cool. And can you go through the model again and how you built the model to do all these predictions?
Okay. We tried using different models. We tried support vector classifier, did K nearest neighbor, but what gave us the best accuracy was random forest classifier with an F1 score of about an accuracy of 97%.
Okay. Well, one thing I will be interested in seeing for sure, I don't know if you showed it, is kind of like a graph of the different workout patterns that we can visualize so that I can see what you're doing visually. I don't know if you have it like a graph, like a time series graph.
Yeah, we have some of these
okay.
Graph that shows different activities based on the different sensors that is put on the left ankle, right arm, and the chest.
Okay, so can you explain this over time? How do you know which one is which? If I'm doing a workout routine continuously?
Yes, so the sensors are placed on 3 different parts. We have 3 different sensors placed on one on the left ankle, one on the right arm, the one on the chest. Each one has, okay, the sensor on the left ankle has a gyrometer and accelerometer. And each of these sends signals of the kind of activity going on from that part of the body. Now, a combination of each of these, of all of these sensors is able to come up with a particular activity. It's able to predict what the particular subject is doing, whether running or cycling or jumping, or if there's no exercise at all going on.
Okay, this is interesting, but it will be interesting to see like an exploded version of the time series so that I can see a repeated pattern. I know the time series graph you have is very compressed, but if you stretch, and you can see that pattern if I'm running for like, let's say 10 minutes, the sensor should be able to pick it. So, and I want to see the repeated pattern of my strides as I run and stuff like that, or if I'm walking out or if I'm rowing, I want to see the pattern. Because this is a way like the Apple Watch and all the smart watch devices work. So the other question I was going to ask is like, were you able to validate this with a real sensor data from a device, or you're just using the test data?
I've just used the test data so far.
Okay.
We can actually try any other available data, even like from subjects from our team to give us the same results.
All right, cool, good stuff. Yeah.
Hey, not much to add. I really like where this is going. I'd love to know what you want to do to improve in the future.
Okay. We intend to actually do more development on this to be able to make smart devices. I believe this can actually go a long way in developing smart devices, wearable devices that can actually be deployed as a device for monitoring mobile health and all of that. So by working on it more, I believe we'll be able to come up with that.
Right. Sounds good. Developing smart devices, that's a stretch, but yeah, look forward to following what you guys are doing.
Thank you so much.
Thank you so much, Wale and Charles and Bjorn. Thank you so much. So the next team, we have neural network. Neural network, please come up. Daniel Kururi and Daniel Ebaidome.
Good afternoon, everyone. My name is Daniel, and I'll be presenting on behalf of the neural network team. The theme of our project is prediction of injuries of athletes. As a common phenomenon, we know injury is a common phenomenon amongst athletes, and every manager or every organization seeks to reduce the events of injury, and which is the core of our project. As such, the aim of our project is to develop a machine learning model that can predict injury occurrences based on the training regimen of an athlete. Our approach, therefore, was to create 3 machine learning models, which are listed here, which is the deep learning, the XGBoost, and the K-nearest neighbors. Our workflow, the first thing we did was to source data, and we sourced our data from Kaggle, where we got extensive knowledge and insights about the data, and we prepared the data in Python. We also created a dashboard using Power BI, and that gave us more insights on the data. Of all the entire record that was contained in this data, we have about 43,000 entries, and of the 43,000 entries, we have less than 2% that are the events of injuries, and about 98% that are events of non-injuries, which is logical because we all expect the event of injuries to be less in an entire record. So this shows a great class imbalance between the two, a very, very large class imbalance. So we got to use the smart technique to mitigate this the imbalance between this class. And also when we conducted our feature engineering, we were able to get some insights. Take for example that the maximum kilometer run by an athlete in a day is the highest contributing factor to an event of injury. And also the next highest contributing factor is the sum of maximum exertion that is done by an athlete in a day. Going forward, we created a model which I had rightly stated before, which is the deep learning, the K-nearest neighbor, and the XGBoost model. The data set that was made available to us is our 2 data sets, which is the daily data set and the weekly data set. When we went through this data set extensively, we were able to uncover that both data sets do not depend on each other, and they are data sets that can be used to achieve the same goal. So not to be left out of the loop, we created a model based on both data sets. So this will be the end. I'll give it to my second to continue with the model.
Thank you.
Thank you.
Thank you. Thank you very much, Daniel. So in continuation with what my colleague has presented, since our data was so much imbalanced, we tried a number of techniques in order to try and ensure that the minority class is not affected. So we tried oversampling, undersampling, and using the smarter technique. The smarter technique gave us promising results, and we developed a number of models out of it, and we selected the top 3, which was at least promising. They included the deep neural network, a deep learning neural network, K-nearest neighbor, and XGBoost. After hyperparameter tuning of these 3 models and finding out the best model, we used a number of metrics to compare them and pick the best performing model so that we can deploy. We used accuracy, precision, as well as recall, and you can see on the screen that the metrics and the values that we got. We used the accuracy precision and recall, because remember our data was so much imbalanced, so accuracy alone cannot work. After doing that, we found that the KNN was performing the best model, was performing the best, and with accuracy of 97%. So we went ahead and deployed for both the daily and weekly approach. Remember, our data sets were from both daily and weekly approach. So we went ahead and deployed the KNN model, and I think I can show you. Please enable my sharing, or you need to stop. Anyway, we deployed our model on Streamlit, and the images that are on the last slide there can demonstrate. I can quickly show you. So this is where our app, okay, it's refreshing. That's the problem about Streamlit. So we fill the data for all the features, and then you can just predict to show us whether an injury is going to occur or not, and no injury is going to occur. So this is the app. So the problem, we deployed the one for the daily. So you need to provide data for the past 7 days. So is there a likelihood of an injury occurring on the 8th day? So you need to fill in for the data for all the data for the first day, which is include number of sessions, total kilometers, and hours alternative, and so on and so forth. So you need to fill in for all the days: first day, second day, that day, fourth day, 5th day, 6th day, and the 7th day. After filling all that, you can just click here to show or to predict whether an injury is going to occur. For now, I think the app has refreshed. So again, I have to refill again for all these days, which is a bit of a task. So I don't think because of our time, I don't think I'll be able to do that. So if you press predict, providing all the data, then it tells us whether there is an injury or no injury is going to occur. Yeah. Thank you very much.
Thank you so much, Joshua. Thank you for the presentation. All right, so Wale and Charles. Will over to you.
Yeah, I can go. I actually do. I like the project. Yeah, thank you guys. My question is, you said you use deep neural network. So what model did you use exactly?
We use neural network.
You just stack like normal neural networks, or did you use like and CNN? Or do you have like a model summary somewhere that I can see?
Maybe, I don't know.
Okay, you can, if you have it, you can just send it to me later on the chat. And then
okay.
Then my other question also is that have you guys thought about recommendation, right? So if you predict that this person is likely going to have an injury, for example, so do you sort of have like feature interpretation, or okay, we're recommending because maybe this person is covering so much kilometers, for example, or did you guys did you do something like that? What do you think?
No,
I think that's okay. You can go ahead, Daniel.
Okay, thank you very much. Based on the insights we were able to uncover from the data set, we were able to see that the number of kilometers run in a particular day contributed the highest to the event of an injury. So our recommendation was based on a minimal kilometer to be covered in a particular day, which should most likely reduce the event of an injury.
Okay, yeah. I mean, what do you sort of mentioned is sort of mostly global importance, so which is kilometers probably adds to that, but that is on average. So I think one very good way to improve these is to also do sort of localized interpretation. So if you have a series of parameters and you're trying to predict for someone, your interpretation is actually attached to that person. So maybe it's not even running so much kilometers. It might be other factors. So I'd say just sort of look into interpretation with maybe Sharp or Lime, and that can actually help improve your sort of your model interpretation, so you can give localized importance or feature importance or recommendation to athletes. But yeah, overall, yeah, thank you. I like it.
Yeah, that was very good. I think Wale nailed some of the things I was going to talk about. Well, great stuff.
Thank you.
All right. Thank you, Wale. Thank you, Charles. And thank you, Daniel. Over to Power BI. Do we have Oluwabukumi Amo and David Appine Quenev?
Yes, you can go ahead. Bukumi, you can go ahead.
All right, good day, everyone. My name is Oluwabukumi Amo. I am presenting on behalf of some Power BI, and we worked on the rainfall prediction. And as we all know, rainfall is one of the most significant factors that affect many aspects of our everyday lives. So forecasting seasonal rainfall systems does benefit us agriculturally and in taking measures against flood, among all others. So the aim of this project is to help us take measures. Now, this is the names of our team members and team leads as well as the presenters. This is the flow diagram of the process of this project. First, the data set was collected from cargo with 21 features and 622,392 data points. It had atmospheric variables collected over different locations, that is longitudes and latitudes from 1948 to 2018. We filtered out the data set for a single location. We dropped some columns where necessary and selected the precipitable water as our target variable. So this graph here shows the EDA and the exploratory data analysis of the distribution of precipitable water over the years. Now here, we had to zoom into the first 3 years and the last 3 years in order to get a closer and clearer look of how the precipitable water was distributed over time. Moving on, for our feature selection, we used the variance inflation factor and calculated the variance inflation factor of each feature. So we compared the calculated VIF of each feature against a threshold and removed iteratively those with the highest VIFs till we finally selected 12 features, extracted them from the training set, and used them to train the model. Here, these are the list of the trained models, and the highlighted regressor, as we can see, that's XGBoost, gave the best results, considering the fact that it had the least mean absolute percentage error. So we tested the model, that's our best model, on our cross-validation data, which ranged from 1988 to 2004, and also on our test data, which ranged from 2005 to 2018. So this slide here shows the trend and seasonality over the years. The first graph, as you can see, shows a not so obvious increase in trend. There was an increase between 1956 and 1978, which continued slowly till 2006 with a slight decrease, but there is still conclusively an increase between 1946 and 2016. So the second graph shows a yearly seasonality with peak values around June, July, and August. Now, this third graph just shows the behavior of the other regressors and models. So right now, I'll hand over to my co-presenter to continue.
Yeah, thank you very much. We were able to deploy this model using Streamlit, and please play it. This is a video demonstrating how the model is used in production. A user just come in and fill in all the values of the features that were finally selected. Actually, then clicks predict. So when it enters everything and clicks predict, the model now returns the prediction of the precipitable water that is available for precipitation and subsequently rainfall. So this is the model as the user is entering the values. Let's see how it works. So when it finally enters and
clicks predict, which now it now returns the result, the predicted result. Yes, that is it. Please go to the next slide, please. Now, in conclusion, with the increasing climate change, we recommend the creation of an automated rainfall service that could receive data on a regular basis. The service would train the model on the most recent data, and then track the progress, redeploy it, and then maintain it until a new set of data is received yet again. And it is also worthy of note here that we had some, although we had some challenges, a lot of challenges in this project, owing to the fact that the data that was provided, we had a very little information regarding it. Even on the cargo where we downloaded the data from, the information, we had a limited information that were provided about the data set on the cargo page, yet we were still able to make some sense out of the data. Thank you very much.
All right, thank you very much, Team Power BI. So over to you, Biodun and Wale.
Hey, I enjoyed your presentation. I honestly don't have any comment or feedback for you. Great work.
Thank you.
Sorry, I was speaking on mute. I think I liked it. I liked the modeling approach. My question would be that if you guys had more time, what do you think you would do differently, or what do you think you would do in addition to your current approach?
All right. Thank you very much. From the business problem, we understand that predicting just rainfall for tomorrow is great, but may not have a great impact as to also how to plan how the team will, how to take some decisions. So it will be better to predict for a whole year, so that whoever comes in, like any stakeholder, will look at the prediction of how rain will fall in the next 1 year or even 2 years and take decisions accordingly. But we also understand that it is very, very difficult task to predict 1 year ahead using regressors, like using other factors in play. That is only possible and easy to do when we are using only the trend to predict. So now, if given more time here, or in the future, we aim to use Facebook Prophet or Neuro Prophet to see how we can use just the trend data. And because we understand that Facebook Prophet has this kind of confidence interval where it predicts what it thinks, the higher bound and the lower bound. So we use that information to incorporate it and predict for the whole year, so that whoever comes in and use the app will see how the rain will fall, as in how the rain is expected to fall in the next 1 year, so that you can take decisions appropriately. Thank you.
Okay. Yeah. I mean, Facebook Prophet actually gives you those confidence bound, and sometimes it's always good to have predictions with some margin of error. My other question is, this data set, what area, what region is it collected from? Do you know?
Yeah, like I said, the data set had very little information in terms of the documentation. But looking at the data set, we saw that it was collected from different locations, owing to the fact that we saw there was a latitude and longitude columns were available. So we filtered the data out for a particular longitude and latitude.
Did you map the longitude and latitude to a geographical area?
Yes, the one we selected, when I mapped it, it showed somewhere around Afghanistan.
Okay. Yeah, because the reason why I asked is that if you look at your plot where you sort of had like the plot of the trend and the seasonality, So you would see that there's sort of seasonality, yearly seasonality, where rainforest is at its peak around, I think, around June, July, right? So,
Yes,
so
yes.
that kind of, yeah, Afghanistan makes sense because, yeah, typically that's how sort of tropical climates would look like. Okay, yeah, thank you.
Thank you very much.
Yeah.
Thank you.
All right, before we go on to Skippy, I would like to say that let everyone stay tuned on this presentation, because we are going to take an attendance. We are going to take attendance very soon. And so if you are found missing, we won't be able to take the attendance. All right, Skippy, we have Joshua Obikunle and Bertram Okonkwo. Joshua Obikunle and Bertrand Okonkwo.
Yeah. Joshua, are you there?
All right. Good afternoon, everyone. Can you hear me?
Yeah, we can.
Okay. My name is Joshua Obikunle, and I have my co-presenter here. Good afternoon. We will be representing Team Scapa. We will be discussing traffic predictions. This was a highly collaborative project. Over here, we have our active members. We have 6 subject matters to talk on, ranging from the problem statement down to our approach towards the project, our modeling, and our arrived conclusion. Before we embarked on this project, we will try to derive insights from the analysis and build the models, in as much making sure certain objectives are met. That varies from latency concern, that is the early response on predictions made, to minimization of the root mean square error, and as well finding the mean absolute percentage error. On the existing solutions, we recognize regularized tensor imputing and forecasting using the temporal regularized tensor framework model. This models traffic data where nodes are junctions and edges are route segments linking junctions. For data set description, we had over 48,000 rows and 4 columns, which were obtained from Cargo. The data was collected in a span of 2 years between 2015 to 2017 at different time intervals. The data quality was not clean because some of the junctions provided had limited data. To our approach, different observations were carried out, from checking missing values, which there was none, to extracting timeframes. Bivariate analysis was done to understand the association between variables, which led us to different models, out of which LGBM was selected and deployed for our working model using Streamlit. Now I'll hand over to my partner, Bertram, as he continues. Thank you.
Thank you, Josh, for that wonderful introduction. For the EDA phase, we'll try to check the level of correlation of other colons on the target colon. We'll also try to extract and visualize total vehicular movement for all the junctions, as well as using the time series chart to visualize vehicular movement volume for all the junctions. Lastly, we'll carry out a bivariate analysis on the junctions. So over here on the bar chart, we will try to visualize all the junctions and how frequently there was vehicular movement. On the y-axis, you have the total vehicles, and on the x-axis, you have the junctions. Junction 1 had the highest cumulative vehicular movement. On the line chart here, we wanted to understand the trend of constant grain rate for vehicular movement, and junction 1 also had the constant grain rate. We went further to visualize the monthly, daily, weekly, daily, and hourly traffic flow using their total averages. For the first graph towards the upper left here, we understood that there was a constant flow of across all junctions. And on the weekly, daily, we understood that towards the end of the week, that's from Thursdays to Fridays, there was a decline in traffic. And for the hourly analysis, we understood that the early hours of the day, there was a decline in traffic, and towards 10 a.m. down to 12 p.m., traffic peaked. So before we went on with modeling, we went on some pre-modeling activities like feature extraction. We tried to extract new features for the daytime colon, as well as using target encoding to create new features. Then we went on with modeling. For the modeling phase, we picked our baseline model, LGBM boost, across other models. And we went on to tune hyperparameters for the chosen model. So over here, we're trying to visualize how LGBM performed across all the junctions and with the predicted values. So you can see how LGBM performed for junction 1, junction 2, and then junction 3 and 4. I would like to make mention that LGBMs work on the actual and predicted values depended on the RMSE score and the MEP score. So because we tested various models across all the junctions, we wanted to show you how well other models performed, and we highlighted our baseline model, which was LGBM. It gave us the best RMSE score and MEP score across junction 1, 2, 3, and 4. So we also gave you a dashboard presentation on the. We want to also give you a dashboard presentation on how our analysis worked better. So looking here at the dashboard, if you load the site. So here, across the dashboard here, if you want to understand how traffic performed for average vehicle by hour, for junction 1, you can easily use the slicers here. Junction 3, you can also use the slicers, and junction 4. So you can also understand that the average vehicle by hour here, this was how it performed. By vehicles by day, this was how it performed. So we also went on with deploying our model. For deploying our model, oh my God, I'm not seeing some. Okay, for deploying our model, we hosted our site on Streamlit. The Streamlit site here, if you want to predict how traffic would perform at a particular day, you simply put it here and you come here to predict. You can always predict it for all the junctions across 1, 2, 3, and 4. And if you also want to host your data set here, you can do that. So for our conclusion, we tested various models during this project. We made use of Prophet, Arima, CADBoost, and the likes. I would like to make mention that Prophet was more robust to missing data. So we didn't go with Prophet because it would have given us chances for overfitting, because we didn't really have missing data in our analysis. So we ended up with LGBM because it gave us the best MEP score and RMSE score. Thank you.
Thank you, Bertram. So your team name is SkyPie, not Skippy. Okay. Sorry.
SkyPie, yes.
SkyPie, yeah, SkyPie. All right, Biodu and Charles, over to you. Thank you very much.
Interesting project. My question really to you all is, where are you planning to take this to as your next step?
Okay, thank you very much for your question. Planning where we plan to take this to. I think traffic road authorities can also use this, like in Lagos, for example. If you notice, the traffic congestion here in Lagos is crazy. As a matter of fact, it's traffic, 24 hours traffic. So I think the road authorities here in Lagos State, for example, could also use this to build more roads and know the right roads to connect in order to reduce the traffic congestion on a particular junction. So in that way, we can have lesser congestions of all the junctions in Lagos. Thank you.
Just to add to that, if you decide to deploy it in somewhere like Lagos where there's a lot of traffic, how do you will this scale considering the number of vehicles on the road? And what do you need to do to improve it to handle capacity?
What we may need to do is to take a lot of things into consideration, like the weather, because we understand that, for example, in Lagos, weather is a big factor. During the rains, you tend to see more traffic at various junctions. So if we improve better on this, we would need more information on how we could take all of this into consideration, and by then making the model more robust to deployment.
Okay, sounds good. Great job.
Thank you very much.
Yeah.
Thank Hamoye for the opportunity. It was a good learning experience. Thank you. Can I stop presenting?
Yes, you can go ahead and stop presenting.
Okay. I think my Zoom is having some issues. Maybe I may have to log out.
Thank you. All right, thank you very much to all the teams that have presented so far. We did mention that we have an attendance form that we would like for our interns to fill. And so the attendance form will be dropping right now. And for those of us with last names from A to M, if your last name starts with A to M, there's a different form for you. And if your last name starts from N to Z, then there's equally a different form for you. And the secret code is Epic Potential. So please look out in the comment sections. You have the form dropping and it's Epic Potential. I'm very sure for everyone that has been a part of this presentation, it has been nothing short of educating and it's been nothing short of an educating and insightful experience. I have actually learned a lot and I'm very glad to have sat back and listened to the work that was done in the various teams. I'm super glad for our judges who came and offered their insights and their feedback to the interns. At this point, I'd like to ask and find out if there are any final words for our interns regarding their performance and perhaps recommendations for future work and projects. Mr. Charles, do you have any recommendations for our interns?
Yeah, I think you guys are trying and doing a great job. This is a great start. Like anything, this is kind of anything you do in this field, this is kind of like your foundation. So beyond this project, I think you should try to keep building on your skills, keep improving yourself, contribute to open source projects. And if you can, if what you're doing is interesting, you can go forward and try to publish it and share the knowledge with other people around you as well. But I think overall, you guys are up to a great start, and I wish you all good luck as you continue your data science and ML journey. Thank you. Thanks, everyone.
Thank you very much, Charles. You heard it. You should not relent in your efforts. Keep doing some more projects and just keep doing your best. Biodun, do you have any recommendations for our interns going forward?
Yeah, all I'll say is, with the Amway sessions that I've been a part of for the past few months, every cohort seems to be better. So kudos to both the Amway team and the interns that are obviously catching up on to newer trends. To everything Charles has said, or Charles mentioned earlier, absolutely look for ways to advance the work that you're doing. Data science is still an evolving field and evolving areas. There's so many opportunities that will come up in data science, and you guys are best positioned to harness those opportunities. There are fewer data science people, and there are very many data science opportunities, and they will always continue to be. So if this is something you're truly passionate about, don't relent, don't give up, and just keep at it.
Thank you very much, Biodun, for that. Wale, do you have any final recommendations for our interns?
Yeah. So I think I would also echo a lot of the things that Charles and Bjorn said. This is an incredible presentation. This is also it's really, I'd like to thank Amway for sort of inviting us to judge and listen to this presentation. I think that's wonderful. So there's always a start, right? And just know that there's no ceiling. You guys can continue to improve on what you've already built. I would say focus on making sure that your algorithm, your testing methods, just everything is foolproof, that there are no sort of fundamental mistakes in what you're trying to do. And then the other part is also focus on communicating your results, communicating your decision. So for example, why are you choosing this model? Why is this better? Sometimes it's not only because of the metrics, right? Maybe sometimes the best model would be the one that you can scale, or the one that you can deploy easily, for example. And so I'd say focus on interpretation of your results. And I think that's always important, and tells a much better story than just the numbers, than the accuracy and the metrics. So yeah, great job, guys. I think, yeah, the sky is the starting point.
Thank you very much, Wale. And to all our interns, we want to say a big thank you to you for your wonderful presentations and the grit that you have demonstrated so far. To our presenters, the various teams, for your cooperation amongst yourselves, coming together to do an amazing job thus far. We are super proud and we want to say thank you. Myself and the rest of the Hamoye team are honored to have hosted you on what was the climax of a rather intense 4 months journey in the field of data science. We can't wait to see you soar in your chosen fields. Please take note of the following. Information regarding the results of this presentation, as well as any other announcements, will be shared with you via Slack and your mails. So please be on the lookout for that. So don't be quick to leave our Slack channels, because information and possibly any announcements we have for you will be shared there. And so on that note, I'd like to say it's a goodbye from me and from the Hamoye team. Thank you for spending your weekend with us, and we hope that you do enjoy the rest of your weekend. Thank you.